Hey guys, welcome back to this tutorial. Today we are going to be looking at pie charts, box plots, and pair plots and heat maps. But firstly, we'll be looking at pie charts. So pie charts are usually when you want to represent your whole data as a percentage. It's also used when you're working with categorical variables as well. Yes, when you're working with categorical variables. So here I've created a because my groups, which is Facebook, Twitter, Instagram, and LinkedIn, and then my views. These are the numbers that I want to represent on a bar chart, and this will be the labels. So I would simply just say, after importing my matplotlib.pyplot as plt, I'll simply just say plt.py, and then my views. That is what I want to represent on the pie charts, and then labels will be equal to the groups. So if I execute this, I would have a pie chart. Yes, so I have a pie chart here, and then that's it. So this pie chart is not fine. It's not fine enough. So we can add some more editing. Yes. So here you would notice that I created a tuple. I named it explode. So I said it consists of 0, 0.1, 0, and 0. So I have 4 groups, and I am representing it with this. So let me add an explode so that you would understand what this explode stands for. Explode is equal to my explode variable. So you see, this Twitter has been cut off from the pie chart just to add some more fancy, just to make it more fancy. So here you will notice that in this sequence 0.1 will belong to Twitter. So if I change this to 0 and I add 0.1 here, you would notice that Instagram will be the one that would explode. So you see Instagram. So this is more finer. I can also add and make, let's say, Facebook 0.1 too, so that it explodes as well. So you see Facebook and Instagram. So you can add different formattings to your pie chart to make it more beautiful. So you can also represent, if you want to see the percentage on the chart, you want to know the actual percent each of these contributes to the total percent, you can add the argument autopect, and here for you to represent for this particular type of format, I'm just simply going to copy this and then paste this here. So when you execute this, you see the percent is represented on it. So this is just the value for the formatting. So 1.1 here to 1 decimal place, that is what it means. So I would, like I said earlier, I would drop the official matplotlib documentation for you to explore more and practice more. So you would see here we have Instagram being 22.0%, LinkedIn having the highest percent, 3.9, and so on and so forth. You can also add a shadow. You can also add shadow to your pie chart. You can say shadow is equal to true. If I run this, so you can see the shadows here. So it's looking more finer and finer. So it depends on you. You can format it, make it more beautiful and attractive, because as a data analyst, your graphical representations matter a lot and it must be catchy. So basically that is just all about pie charts. So moving on to box plots. Yeah. So box plots, I don't know if you've seen box plots before, but box plots majorly are used to represent numerical data and to see if we have outliers in your data. Box plots are like the shortcuts for you to see that, for you to see if you have outliers in your data. So here I've uploaded a CSV file that consists of a pharmaceutical data. So let me see if it's still here, or I have to upload again. Okay, it's still there. Okay, so let's check the data out, so we'll be sure of what we're doing. Okay, this mistake. Yes, so you see we have 4 columns. This number first column seems to be irrelevant. So we have diagnosed condition, patient age, the number of previous conditions. So we have 3 columns in this CSV file. So we want to illustrate this. You notice that all these are numerical variables, they are numerical data. So let's just represent them on a box plot so that you understand why exactly we are choosing a box plot for this particular exploratory data analysis. So the same way, we just simply just say plc.box plot, and then you pass in a list of all the columns you want to represent on the box plot. You can do this way, or you can simply just, let me just cut this out so you don't get confused. Let me cut this out and just represent this with, let me say data is equal to, then I have this. So you see this is just the list. This is the first column, DF diagnosed condition, and then comma, the second column, the third column. So you can also use a for loop to iterate over the columns if you don't want to write it manually like this, but I'm writing this manually because we have just 3 columns. So that's just that about this. So box plot data. Yeah, so you would see what I mean by box plot. So this is a box plot. So this box plot, to make an inference, so this first box plot, to make inference from a box plot, let me just explain what it means. So these things you are seeing here, this line here represents the minimum value in this particular data, in this particular column. This is the minimum value, the least value here, and this is the maximum value. And this line that you're seeing here, it represents the median value, and then here is like the 25th percentile, and here is the 75th percentile. So whatever lies beneath this minimum value or above this maximum value, they are called outliers. They're called outliers. So here it appears we don't have outliers here. So for this first column, we don't have outliers here. So the way you check this second, what is it called, this second box plot, it's very small. That means we have just tiny data sets here. So it appears most of the data is distributed between 0 and 1. So that's why it's very tiny here. But we seem to have outliers. You can see this black, they lie above this top value. So there are outliers here. So in this third column, we don't have outliers. So that is just that about box plot. So it will let you have an idea of how your data is distributed. If you have outliers, what to do about it, and it's a very interesting way of illustrating your numerical data set. So there are different ways by which you can format your box plot as well. You can make the outliers a different color. You can simply just say 0, and then you can put GD here. Did I spell this well? No. GD. Like I said, this is not something you should cram. You see here, the outliers they are colored green so that you'd understand it better. So that is a simple way to format your box plots. All these are available on the documentation site. It's not something you would cram or anything. So they are available for you to use whenever you want to use them. So you can also make your box plot horizontal by just simply using the RS, and then you put comma and 0 here. So you see we have horizontal box plot. So this one is a lot more prettier. So here you see this two appears a lot more better here, this second one. So you see we have the box plot here. The minimum value here is 0. That is why there is nothing beneath here. And we have maximum value here, and we have outliers here. So that is just that about box plots. So you can read more on it on the official documentation site. So matplotlib is a very interesting and a very awesome library. In fact, you cannot it's inexhaustible. So you would learn the more you practice with it, the more you use it, the more you understand and better you get at it. So you get better by the day. So I would implore you to practice this very well using different data sets. I would upload data sets on the Slack channel so you can explore those data sets and then draw insights from them. So that's just that about the matplotlib. That's basically what we'll be covering for today on the matplotlib library. So see you in the next tutorial.